This Equipment World video is brought to you by Chevron Delo 600 ADF Ultra Low Ash Diesel Engine Oil. It's time to kick some ash. Hi everyone, welcome back to Equipment World. You're watching The Dirt. I'm your host Brian, and today we're here to talk about something that we all think we know a lot about, but it turns out the majority of us don't really know that much about it. And I'm talking about fluids. Your oil changes, your hydraulic oil. These are all things that as an industry we kind of just assume we know how to do it correctly, and we assume we know how to do a good job taking care of our machines. But when it comes to lubricants, the industry and the people that are experts in that field actually have a totally separate way of thinking. And to help me today, we have Rebecca Zwetzig. Yes, that is her last name. It took me a second to figure out how to pronounce that. She is America's ISO Clean Program Manager. And what does that mean? Essentially, they're in charge of getting lubricants to their customers with a certain cleanliness standard. And that's what she manages. She oversees that program. But before we get into that, I want to take a second to tell you about the sponsor of this video, Chevron Lubricants. Protecting your diesel engine and its exhaust aftertreatment system has traditionally been seen as an either-or proposition when it comes to choosing the engine oil that's going to protect your system. And that's exactly why Chevron spent more than a decade of R&D work developing a no-compromise formulation. Now, I don't have to tell you why a clogged DPF is bad news, but here's the real kick in the pants. 90% of that ash clogging up your DPF and then upping your fuel and maintenance costs, it comes from your engine oil. You might be thinking, why don't they make an engine oil with less ash in it then? You'll be happy to learn that Chevron agrees with you. They've developed a new ultra low ash diesel engine oil that is specifically designed to combat DPF ash clogging. Delo 600 ADF with OmniMax technology cuts sulfate ash by 60%, radically reducing the rate of DPF clogging and extending the DPF service life by 2.5 times. Before you had to choose between protecting your engine or your aftertreatment system. Now you don't. Delo 600 ADF with OmniMax technology. It's time to kick some ash. Well, Rebecca, thanks for being on the show and taking some time to talk about lubricants with us today.
Yeah, thank you, Brian. Really appreciate this opportunity to be here and speak to a broader audience about the importance of lubricant cleanliness.
Absolutely. So with that being said, let's jump right into it. As an expert in the field, what would you define as a clean lubricant?
I'm going to just start by saying there's a various set of classification systems that can be used. So for the sake of today's call, we're going to talk about lubricant cleanliness in terms of ISO 4406. Some others may be using an older system called the NAS, which was replaced by the AS 4059. And I know I'm throwing a lot of letters and numbers out there, but for those who are out there and familiar with it.
So as a total rookie to this, what are those classifications that you're throwing out, just out of curiosity?
Yeah, they are all different standards that describe a testing methodology on how you quantify the amount of contaminants in terms of the particle contaminant size and the distribution of the level of size of contaminants within that fluid. So the ISO 4406, just for today's conversation, measures fluid cleanliness at 3 different levels: the 4 micron and greater, 6 micron and greater, and size 14 micron and greater. Just for conversational terms, people can't really see below the level of 40 micron. When you think of like a white blood cell, that's around a size 20 or 25 micron. So we're talking about stuff you can't see with the human eye. That's why
tiny particles.
Absolutely. That's why you have to have a laboratory test it and really tell you how many level of those contaminants are in that distribution size. So for today's conversation in terms of what is a clean lubricant, we like to talk about it in terms of ISO 4406, where you'll get a 3-digit code, something like a 151310, that again is saying there's this many size particles of this size in that distribution. So how do we define a clean lubricant? It really depends and varies on a couple things. First, it depends on that component being lubricated. Is it a pump, a valve, a bearing, an actuator, a gearbox, etc., and what type of fluid is in there: hydraulic, circulating, turbine, gear, engine oil, etc. And then also with that is consideration on how that system is operated. Its duty cycle, the system's pressure, the sensitivity to contamination, largely the clearance size within that component, system life expectancy, replacement cost, and downtime, as well as safety. That's another big issue in terms of, making sure that we get the right fluid cleanliness level in that component so that you don't have premature or unplanned failures due to wear and tear. So if I had to answer in generalized terms, again, coming back to that ISO 4406 specification, what is a clean lubricant? Again, these are general, I can't say verbatim, but in general terms, for a servo valve, ball bearings, or cylinders, you would want a 15-13-10. For proportional cartridge valves, directional valves, flow and control or pressure control valves, you would want a 16-14-11. And then for a lot of your pumps that are out there, you would want somewhere between a 16-14-12 to a 20-18-15. Again, the tighter the pressure, the tighter the clearances, the higher the pressure, you would want to lean towards that lower or cleaner ISO code. For gearboxes, a target of an 18-16-13 is a great starting point. And for things like motors, radial pistons, axles, you should start somewhere between a 17-15-12, again, to a 20-18-15, keeping in mind, again, higher pressure, tighter clearances, higher costs. If it goes down, you might want a cleaner fluid. And then kind of rounding that out with transmissions, you would probably want somewhere like a 16-14-11 for hydrostatic, and then other ones up to a 21-18-13. So very specific there of how would you define that clean lubricant. Hopefully that gives people a good starting point.
So just to kind of distill this down even further to make sure I understand it correctly, it would make sense to me in a modern diesel engine with very tight tolerances, you're talking very, very small amounts of very, very small particles versus if we were to throw an oil in some 1985 bulldozer that's still around and kicking, you could get away with much more contaminants in the oil simply because the engine has the tolerances that you're not going to get necessarily the abrasive wear that you would in these newer engines. And I know that's not exactly 100% true, but just a general idea.
You're 100% right, Brian.
Okay,
I mean, the way OEMs have evolved is they put smaller sumps, higher pressures, there's more heat in those systems, tighter clearances. So newer equipment is more sensitive to contamination than some of that older equipment that was out there.
Well, now that we've kind of at least got our mind wrapped around what a clean lubricant is, what are contaminants and where do those come from in an engine?
Contaminants are basically unwanted materials in that oil, right? Solid particles, dirt, rust, metal chips, paint particles, rubber, fibers, metallic salts, etc. Anything from that environment. Or there can be fluid contaminants such as water, coolants, acids or gels, can wreak havoc on equipment too. Sometimes when people put in those additive top-offs for your oil, they might not understand the chemistry and you can get a byproduct and again, wreak havoc on that system for performance reliability. So contaminants can really just come from the environment, be built in from, metal filings from welding and things like that, slag, or, can happen from other contaminants just in that, within that system.
So just to back up for a second, you said something that really piqued my interest there. Was that metallic salt?
Yeah. So if you're a mine, a lot of times you might see silica come in or sodium creep up. It could be salt that's out there. There's a lot of salt beds that have been out there where people are running mining equipment that might show up within your fluid analysis. This
is why I love doing this. I learned so many things that I never would have known about before. And now metallic salts is one I can add to the list. So that being said,
there you go.
At what point does a fluid need to be changed? And then as a shop manager, as an equipment manager, how do I determine that at my level in my shop?
The lubricant condemning limit, I'm going to start out by saying, is going to vary, again, by that fluid type, your OEM specification, and sometimes your own site-specific operational environments. So just for example, a condemning oil on a diesel engine oil is going to be different than your turbine oil, your hydraulic fluid, your gear oil, etc. That's why there's a lot of different lubricant testing packages offered out there by commercial labs. So it's important to talk with your lab and understand about what you are wanting to do with this data so that you're getting, the right data in that test package and measuring it the right way. A great example is we have a new diesel engine oil formulation within Chevron where we have gone away from measuring base number to measuring acid number, because that will be an item that moves within that fluid analysis first to determine a condemning limit over the base number. So again, just, what you're going to be condemned on is going to vary by a variety of factors. So, setting that goal, again, what is it that you want to manage and monitor? For example, if it's a diesel engine, a lot of people like to just look for coolant leaks, right? Is my potassium, going up? Et cetera, right? Is that indicating that, potassium in water, et cetera? Is it going up so that I can see that I have a coolant leak and then I take action on that? Or am I using this data to say, hey, everything looks good, my wear levels are low, I should start to push this drain interval, right? The oil is still good, it's still suitable for use. How am I taking this data to that next level to improve my business? In addition to that, are you trending out the wear rates, your iron, your tin, your copper, et cetera, and saying, hey, by my managing my fluid cleanliness, am I seeing those wear rates drop lower? How much longer am I going to be able to extend that component life? You can start to use this data to get into predictive analytics. And then, really collecting that data to just improve that maintenance strategy. Again, optimizing your equipment rebuild schedules, your planned downtime, streamlining when you're going to change fluids on multiple components within that system to, again, minimize the downtime of that component coming offline. A secondary benefit of implementing that fluid analysis is a lot of companies end up extending that drain interval, even if they weren't planning to. They might just be looking for some issues, but a lot of times those OEMs have very conservative drain interval estimates because they want to capture all, right, in that bell curve. And so you can really push that out. And another benefit is just that time savings. So overall, the bottom line is when you're using fluid analysis the right way, is that there are a lot of benefits that you can reap that may not have been initially sought. So just ask experts out, get the right test package, and then start using the data to really improve that business.
So it is interesting the way, and you're probably, I think this is the third interview we've done with someone from Chevron, and it's interesting the way you guys talk about fluids versus the way I have traditionally talked about fluids with contractors on the job site. For us, most of the time it's like you just mentioned, it's every so many hour interval you're going to do an oil change because it's time. But you guys have all been very consistent in the standpoint of stop thinking of it as this hard and fast milestone you change a fluid, and you're actually getting into testing the fluids and doing the actual chemistry analytics on those fluids. So I guess my next question would be, is fluid testing really something that you would recommend for every contractor to start getting into, or is that something that can be done in-house? How is that generally handled?
That's a great question, and kind of just come in full circle. We really stand on the fact that you want to do condition-based maintenance, right? Look at that fluid, look at that situation and the condition of where it is today, and make those proactive steps on what you need to do versus a time-based maintenance. It's really getting into that maintenance strategy at that individual level. So I've already forgot your question, Brian. You're going to have to repeat it. I was kind of getting caught up on this.
Yeah, no problem. It's essentially, would you say that off-site testing is pretty well required for coming up with this sort of a maintenance schedule, or is this something that you can do in-house with tools within the shop?
It really comes down to that particular location and what they're looking to test and to measure. It also comes down to what laboratory equipment is needed to conduct the testing. There are ASTM methods that the OEMs and the lubricant suppliers specify to say this oil is still good, for continued suitability for use. The OEM says, hey, once you've reached this threshold of metallic wear, certain changes need to take place, right? Or certain cleanliness levels, right? Hey, Allison transmissions come to mind. If you exceed a 24 something, I think it's a 24, 22, 15, your fluid is contaminated and you need to replace it. right? So your OEMs have different specs about what they're going to say. And so some companies who choose to invest in their own lab equipment, and I get it, it's a quicker turnaround time, especially if you're in a remote location where there's a longer, maybe turnaround time on mailing. However, when you balance that turnaround time, which most major commercial labs are going to get back to you within a 48-hour period after they've received that sample, versus the cost of building that in-house program and the personnel resources to perform the testing on site, you really have to balance all of those different things. One thing that I like for people to keep in mind is that when you're building your own program, make sure that you include your lubricant supplier and OEM to make sure you have all your specs identified before you start going to get equipment, so that you really understand what data you're collecting and that you can collect it the right way. I've seen some companies build their own in-house program only to find out they're not testing the right things and they're still having those failures, and they invested a lot of time and money in a program that wasn't netting the results. And they come back and go, oh, fluid analysis isn't worth it. Again, measure twice, cut once, really engage the right resources to look into it, and make sure that you are defining what your goal is and how you're going to use this data so that you are collecting the right data to measure.
It does occur to me as you talk more and more about this sounds like some very sophisticated measuring tool. Well, I mean, when we think about we're measuring to microns on the particulate size, this doesn't sound like something that Billy Bob in his shop can go back there, watch a couple YouTube videos after spending $4,000 on the internet and be able to run these samples himself. It does sound like, to an extent, you really have to send this to an outside firm that they specialize this. They have qualified individuals doing it.
Yeah, and again, it comes down to, as I mentioned earlier, there's different classification systems for measuring that level of contamination, right? And just even in that same amount, there's different instruments. You've got direct imaging particle counters, you've got laser light particle counters, you've got pore blockage, etc. And they all have different pros and cons. So you really need to understand that the devil is in the details about what you're measuring and what data you're getting.
Well, now that we've kind of established what a clean lubricant is, how it gets contaminated, kind of what's involved with that, let's start talking about what are the long-term impacts of running with dirty lubricants, other than, the engine blows up, which is what we generally think of. On your side of it as an expert, what are the long-term benefits of running dirty fluids?
When you have a dirty fluid, that particulate contamination is causing abrasion, erosion, and surface fatigue. So let me define those real quick. Abrasion is when particles are caught between two moving or reciprocating surfaces. You can have what's called 2-part or 3-part particle abrasion. And that's actually your largest bucket of when we break down wear and tear, where a lot of wear comes from. Erosion is what occurs when particles are moving in a high velocity fluid and damaging the metallic parts on the inside of that equipment. And then you have what's called surface fatigue, which is where the damaged particles are repeated to stress and you get little cracks and it just breaks down over time because that metal has been damaged on the inside. These different wear mechanisms are damaging the system by having high level of component wear, the formation of sludge, as that oil ages and you've got high temperatures, you can get byproducts like varnish in that system. System leaks due to, again, seals are a very soft material and the particles are going to eat away at that first. So O-rings being worn out. And your seals and seeing, a lot of people complain about hydraulic leaks. Well, there's a set reason about why those leaks come in, particle contamination being one of them. The destabilized system pressures, right? You have vein pumps out there, right? And you get chatter in that system at a very minute level, but it affects that system's pressure and you have reduced equipment availability. You can have a reduction in the film, the dynamic lubrication film. You have shorter oil service life due to accelerated oil aging. And then ultimately, that system failure. I love to quote this. MIT has a study where they shared that 70% of machine life is due lost to surface wear. Noria and STLE, which is the Society of Tribology and Lubrication Engineers, has identified that 82% of that wear is attributed to particle contamination. So people who are not paying attention to fluid cleanliness have an issue.
That is interesting. It is, again, it just continues to fascinate me, just the way that you guys think about and talk about lubricants versus the everyday Joe out there on the job. It's, you look at your hydraulic fluid tank. Is it low? Nope. All right, we're good to go. Keep rolling. And I would say probably, and this is totally off the cuff, 80% of your contractors, that's the way they think about it. It's not really until you start stepping up into these multi-million-dollar companies that they really start to hone in and see the impact of this wear in the engine and the impact on the equipment and the long-term costs associated with that. So it's just it's interesting to hear your perspective on all of this.
Well, thanks, Brian. I like to think that when we know better, we can do better, right? And lubricant contamination has been an issue acknowledged for a long time, over 70 years. Really started with NASA and your rocket lubricants and your aviation, right? We've all known how critical that is. You don't want life lost over, something as simple as a fluid not being clean enough and that component failed. And now that we have taken those lessons learned and we've applied it in a lot of different ways, we have seen the benefit. And I think it's just about creating education and awareness so that others can say, hey, this is a condition-based monitoring tool, right? If I look at that fluid analysis, look at that fluid cleanliness, and I have the right measurements in place, I can use that data to really impact my business.
So now I have a question for you. So we've been talking about the contaminants associated with the engine running. One thing I've always been told in the industry, if you've got an older piece of equipment that's been sitting in the yard for 6 months to a year, it hasn't run, that you need to bring it in and do an oil change. Is there truth to that? Because in theory, according to what we were just talking about, there shouldn't be any contaminants because nothing's really been running to contaminate the lubricant in my mind. But tell me, should we change the lubricants?
I feel like I'm not giving direct answers, but again, the short answer is it depends. As I mentioned earlier,
run a test, right?
Yes, all of the above. No. As I mentioned earlier, each system and component can have a different tolerance to contamination. So I'd suggest that if someone's concerned about contamination in a system, especially if it's sat idle for a period of time, first collect a representative oil sample if you don't have to run it right away. Send it in for testing and look at the fluid. See if that fluid is still suitable for use. Maybe there's a bad seal in there and it was sitting outside and rain has been taking place, or different temperature swings and condensation has built up in that system. Those systems aren't airtight. They breathe too, right? And if those temperatures changes, that lubricant expands and contracts. That's what hydrocarbons do. So that system is breathing and it hasn't been circulating through the filter. There's onboard filters on equipment for a reason. It's to maintain that fluid cleanliness because lubricant cleanliness is important. So for what it's worth, I'll share that, Noria has documented it costs 10 times more to remove that particulate contamination than to prevent it from occurring in the first place. So my advice is if that a machine's been sitting for a long time and you don't have to run it right away, get a sample. If you do have to run it right away, if it was my equipment and it was costly to replace, or it could create a safety hazard or it would disrupt my operation, I would just change it out because it's cheaper to do that than to deal with the results of what contamination causes downstream.
So essentially, it's a classic case of when in doubt, play it safe.
Absolutely.
What are some steps I can take as a business going forward to kind of prevent contamination in lubricants and kind of extend the duration of the lubricants in my machine?
Let me just start by saying I recently obtained my CRL, which is Certified Reliability Leader certification. And something that floored me was when they said 84% of random failures are due to careless work habits. So I would say when it comes to lubrication and a lubricant maintenance program, you want to start with a lube survey. And that means understanding how your lubricants are stored and handled. So some tips that you can do to be proactive to make sure that you reduce the risk of your oil getting contaminated is, start with using oils that meet your fluid cleanliness specification. A lot of OEMs have specs out there. If you're not sure what that spec is, reach out to your lube supplier, reach out to your OEM, or in terms of like hydraulics, because there's a lot of different hydraulic components and a lot of different OEM suppliers in some of these large industrial plants. There's another ISO document called the 12669, which actually provides you a calculation to help determine the recommended fluid cleanliness level for your hydraulic fluids in your particular plant. So that's something to look at. Keep your lubricants in a temperature-controlled, clean room where it's not exposed outdoors. You know, if you have a bulk tank sitting within your plant or a drum or a container that you're using for top-off, don't ever leave that exposed to the open environment. Again, the contamination that does the most damage is the stuff we can't see with the naked eye. And a lot of these facilities, as you know, or where the equipment operates, is in a dirty environment. So there's that dirt and particulate. Implement the correct tools to manage your airflow or the headspace. You know, desiccant breathers are something we talk about, air filters on those tanks. Develop a program to replace those filters and breathers. And I know some guys are saying, hey, you know, you can dry that desiccant out. Watch, I'm going to blow the air in it, and they blow the air through the desiccant breather right back into the lubricant.
But it sounded good.
That defeats the purpose, right? So we got to, yeah, you know, I have to change it. Just sit here for a while. Anyway, yeah, just all your hose fittings, you know, your devices used in that lubricant transfer process are capped and kept clean. You know, cleanliness is next to godliness here, right? And just really, you know, make sure your equipment is identified. You know, the worst thing you can do is not have oil in the system or put the wrong oil in the system, right? So you want to clearly identify it and then maintain that fluid really as like an asset in itself, because it's an asset that protects your physical assets. So use a good labeling program. I can't emphasize enough about training. There's not a lot of trade school programs out there that are focused on lubrication. A lot of these guys have to learn it from their employer, and many of your suppliers are happy to provide it. You got a filter supplier, they're happy to provide training. You got a lubricant supplier, a lot of times they're happy to provide training, or even have computer-based trainings, because a lot of us can't meet in person nowadays, right, with COVID. And then just really one of the best things you can do is avoid changing the oil. Avoid touching it until you need to. So again, optimizing that drain interval. Use that fluid analysis. Don't touch it unless you have to. Again, getting back to that statistic that 84% of random failures are due to careless work habits, right? And honestly, to kind of bring it all together, just keeping in mind if you manage the environmental air, that's one of the biggest culprits of dirt ingression into that equipment. So you can bet on the fact that if your oil is exposed to the open air, it's probably got contamination in it.
This has been super educational and super, you kind of hit the nail on the head. Through all of the education I've received in this industry throughout my entire time, there has never been an emphasis placed on lubricants or maintaining outside of just making sure you don't accidentally drop some dirt in your hydraulic oil bucket or in your engine oil bucket when you're changing things out. Or my favorite, and this one still gets me every time, is you can use that dusty, old, nasty funnel that you've used for everything else. Just take a paper towel and wipe the area that you can reach, and it should be fine. You've got a filter in the machine. And I'm just going, okay, but that doesn't make sense to me. And I think you just nailed that one right on the head. That is totally unacceptable practice that's going to eventually, over time, destroy the machine. So very, very informative. Thank you very much for all of this information.
No, great questions. Thanks for asking.
Absolutely. So that kind of wraps up my questions. I had one final question that you kind of nailed through that whole last answer, which, and I guess we can go to it. If you had one thing that you were going to implement to improve the cleanliness of your oil, what would that thing be?
Yeah, Brian, I think you just summarized it. There's just this industry-wide misconception that, oil operates in a dirty environment, so it's okay to be dirty. And that you have to spend a lot of money to make these small improvements. They're very low-cost tools. And anyone I know who's shown up to their work, they all want to do a good job. We all want to do a good job. And we all want to be more efficient at our work. So if we can provide the knowledge and the tools to help people be successful, and then we can measure that progress with data, with fluid analysis, it's easier to help show people the light, right? and to get people to stick with those better practices. So use the data to drive those decisions for that capital investment. And we've seen, again, time and time again, where people apply good, clean practices. They start with a clean lubricant. They're measuring with the data and looking at the data to make good decisions. They're having significant results with reducing wear and tear, extending component life, extending oil drains, getting more time and more resources, which all of us are looking for more of that nowadays. And really, in short, to kind of summarize it, just lower your cost of operation.
Well, thank you again. Like I said, this has been super, super informative. I really do appreciate you taking the time today.
My pleasure. Thank you so much, Brian.
So there you go. Like I said, I thought we knew what we were doing when we changed lubricants in this industry, but it turns out I have been grossly misinformed and I feel very undereducated in this area. And I really want to thank Rebecca and the people at Chevron for helping shed some light on this area. If you have any questions on this, because I know we threw a lot of information at you, we threw a lot of numbers that even I'm not sure I 100% understand. But if you have any questions, absolutely drop them below. Feel free to reach out to the folks at Chevron, and we'll catch you guys at the next episode of The Dirt.